Hello, so today I will be showing how to use Python to map earthquake data. So we're going to start by getting our data from USGS. They provide lots of data about earthquakes. We're specifically going to look at the past 7 days, and I'm going to download this CSV file for all earthquakes. Then we don't necessarily want all that data to start with, so I'm gonna go ahead and open it up and make a new Excel file. And I just want the time, the latitude, and the longitude, which are very important, the magnitude, so the size of the earthquake, and I'll take the place, and then I'm going to add my own column for the date that's going to be a variation of the time column. So I'm just going to only take the date portion. And then I'm going to fill that downwards. There's probably a much faster way to do this, but we're just going to drag tonight. Almost there. Hello everyone! Just getting started setting up our earthquake data from USGS. And here we are at the bottom. Perfect. Now I'm going to save this in my folder as a CSV file. I'll name it earthquake. Okay, so now I'm going to be using Jupyter Notebook, and I'm going to start by importing my library. So we definitely need Panda. We definitely are going to need our Plotly graph objects, which you might not have installed, so you might need to install that additionally. And if I have time, I'll be using that as well. Okay, so now that our libraries are imported, we need to import our CSV file. So I'm going to use pandas because they have a nice handy read CSV. So earthquake.csv, and then I'll print it out afterwards to make sure it imports successfully. Okay, great. So it looks like all of our data is here. So now what we want to do is create a header. So for one of our maps, it's going to have little pinpoints that show up to give specific information. So I'm going to make a new column called header, and I'm going to import, or I'm going to combine magnitude, but we need that to be a string. So as string plus a comma to separate, plus data. I want to put the date and another comma to separate. Forgot that space. And I'm going to put the place as well. So let's see if that worked. Okay, that worked. So now if we print out data again, we'll see that we now have our new header that has the magnitude, date, as well as a more specific location that's easier to read than latitude and longitude. So our first figure is going to be a sort of scatter plot on a map. So that's going to be a figure, and we're going to say it equals our graphical scatter geo. So now we need to give it our data. So longitudes in our object column, looks like it's called longitude. Latitude. This is how it's going to know where to put our earthquakes on the map, is based on the longitude and latitude. Now, whenever you hover over a point, we want to bring up this header column we made. So we're going to set text field equal to our header column. Don't forget the commas. And then our mode is markers, since we're plotting points. I'm going to set the marker color is going to be proportional to the magnitude of our earthquakes. I'll specify more what that means here in these options. So making a dictionary, and I'm going to give it a color scale of spectral. That's one of my favorite color scales because it's sort of the rainbow, and so it's nice to have the red be the high values and the blue be the low values, but that's not the default, so we have to set that. We have to say reverse scale equals true. And then finally, I'm going to give my legend a title of earthquake magnitudes. Before I show the figure, I'm going to update the layout and give it a title. Updating the layout is a very handy way you can come back to your figure and add different features. So all earthquakes for the past 7 days, data from USGS, important to credit our data source. So now if I run that, oh, syntax error. Let's see what that could be. Maybe it doesn't like the space. Who knows? No. Okay. Ah, there was no comma before. Knew I would forget one of those commas. Okay. And so this is the map we get. So our color means the red is high, blue is low, just like we wanted. And we can see that if we hover a point, we can see where the earthquake was, the magnitude, the date, and it shows us the latitude and longitude. So we see some high magnitude earthquakes here, and we see a large, massive, low magnitude earthquake sort of in the Ring of Fire area. Oh, and we can zoom in on this map, which is very nice as well, and drag around the world, and it's just an infinite loop, which is sometimes fun. Now, there's one other type of map that I think is fun to make, and rather than showing points that show the magnitude, it shows clusters of earthquakes. So it shows us where there's a lot of earthquakes as compared to where there's a low. So that would be more of a heat map idea. So we can make that quickly. So a density map box is what it's going to be called. Our latitude, we'll put it on separate lines for readability. It's going to be equal to latitude of our data again. Longitude equals data longitude. Our z value is going to be our data magnitude. And radius of our points, bubbles, is going to be 10. And I want to put my own color scale on this. So I'm going to set auto color scale equal to false. And then I'm going to give it my own color scale, which is just going to be a yellow, orange, red. So that's one of the color scales that Plotly has defaulted. So instead of putting in hex codes, we can just put a basic text. And then I'm going to update my layout like before. And I'm going to give it a style for the map box. So there's a bunch of different base maps we can use. You can use open map data, as well as other satellite data. Although for satellite data, you do need an API key. That's probably not free, although I'm not sure. But one of the non-API key is Cartopositron, and I like this one because it's very simple, black and white, easy to see our data on top of. And then I'm going to set the center longitude equal to 180, so that will be what the center of our map is. And another update layout, I'm going to set the margins of our map. And they're all going to be 0, so right, 0, top, 0, nope, did not want to go outside that parentheses. Left, 0, and bottom, 0. And that should be it. We should have our map here. And nope, close. Oh, I forgot the equal sign. Okay, now we debug. Always an important step. Let's see, what's there? It did not like my longitude. I wonder why. Okay, well, we'll put these all in one line. Maybe it doesn't like this. Nope, that is not it. Okay. Give me a second and I will figure this out. Ah, because I put long instead of longe. That's longitude without the G. Okay, and here we have our heat map. So as we saw above with these large clusters of low magnitude earthquakes in this area, we have our heat map showing that there is a very high concentration of earthquakes here, as opposed to some of these larger magnitude but less concentrated earthquakes over here. So yeah, that's how you map earthquake data in Python. Hope you all enjoyed. Bye.